Hi, I'm Dr. M. Kamakshaya, open source software evangelist, and I'm also a freelance full stack developer. Please visit my GitHub page to know about all my free and open source software applications. I've been filming about R and RStudio for the last couple of sessions. In my last session, I explained about how to perform descriptive analytics inside R. I actually imported a dataset which I simulated using Excel. This is just a small, makeup data which I created in Excel, and I saved it as CSV file, and then later I imported it using some certain basic functions inside R. Now, I was trying to explain a particular phenomenon called normality of this very first column called age. Now, I was not correct exactly in my tune while explaining or making observations on this particular variable age. What I did is actually I just computed mean, and then of this variable it is 50, and then I computed standard deviation. By the way, these are the two very important statistics in descriptive statistics. And now I said that it is for this distribution the size of mean is too much and there is a lot of dispersion, but that is not correct. Why? Because I created this data variable by using a particular function inside Excel known as run between, and while doing that activity I preferably created using two limits, that is lower limit and upper limit, which means a minimum value and a maximum value. The minimum value for this distribution is 20 and the maximum value for this distribution is 80. So for any distribution which starts with 20 and 80, the mean of 50 is exactly not unsuitable, which means this is a suitable mean for this type of distribution. Imagine that we are going to add 20 data points left side and 20 data points right side, so that we are going to start this distribution, imagine that we are simulating this distribution from 0 to 100. Obviously the mean is going to be 50. So that is not a big thing. I said there is a lot of noise because there is dispersion of this dispersion. If you observe very closely, this is just close to minimum value in the distribution. So for a value of mean 50, having 23.28 as scattered, the value of dispersion is not that vicious. So this distribution is not, that noisy. However, it is not possible for us to state that whether this is normal distribution or not. There is one very particular technique in descriptive analytics. Actually, descriptive analytics is equal to numerical analysis plus infographics, which means graphs and pictures. We need to make a couple of plots in order to verify that whether this is normally distributed or not. In R, you have a beautiful function called histogram. Now I'm just going to plot a histogram. For a histogram is one of the visuals which is very handy while taking decisions about normality on data. Now I'm going to plot this age histogram using age. There is a particular parameter called frequency. I need to make it false if I want to have density in my plot. Now you see this is a bimodal distribution. Now it is not possible for us to understand without a curve. Let me create a curve, lines and density of my df age. Now when I press this, you see there is a curve, and this curve clearly shows that this is not normal because it is unevenly scattered. And you see there are two models, so this is a bimodal distribution. I'll make lines a bit line width thing LW. I don't know. I'm just using this line type LTY, right? I forgot. Yeah, line type 2. Yeah, 2. And now I make color is equal to red. Now you see it is clearly visible. This dotted line is actually the overlaying curve on the histogram, and there are two. This is a bimodal data, so this is obviously not the normal distribution. Normal distribution never looks like this. But having 50 is not an obnoxious value in this distribution, and I don't even think the scatter, the dispersion element inside the distribution is that vicious. Now it is okay. In this session, actually, the purpose of this session is not to explain descriptive analytics. I just wanted to show you. Suppose if you would like to plot gender, and gender is let us finish the full descriptive analytics tutorial. As I said, descriptive analytics is numerical analysis together with plots, this plot. And now if you would like to use this plot, you just have to press on this export button. You have two options. Either you can save this as, or you can also copy to clipboard. If you can copy to clipboard to copy plot, then open somewhere your Word document, and my computer is a big junk box. Hopefully I should be able to open my Word file in no time. You can just press copy. Now you can export this, because people ask me, like, how to get these pictures into Word application. You have multifarious ways to export these plots once you create inside R. So there are every petty way, because R is not just a type of tool like SPSS and PSPP. It is very highly matured programming. I mean, the very advanced programming language used by the mature researchers. Now I am going to show you how to plot this variable gender. Now let's say gender is male female kind of data. This is exactly, I don't think this is either nominal or ordinal. Suppose if you have 1 comma 2, one male and 2, even either in this, I mean, even in that case, it is not going to be the ordinal. It is somewhere, this gender kind of data falls exactly somewhere between nominal and ordinal. It is, I can say, neither nominal nor ordinal kind of data. Now for this type of data, there is a property called table mydf and gender. Now you see we have 11 instances of female. I mean 11 individuals are female, 5 individuals in this particular sample or male. So we have very less number of male individuals in this survey, and most of the, I mean more than 50% of the, I mean male individuals are not even 50%, close to 50% of the. Now if you have a table just like this, you can just plot this table. Now let's see what's going to happen if I use this base function plot over this table. I have this in history. I just have to add the, well, you don't need to type entire. Now let just me use plot and see what's going to happen. Now you see there is a very beautiful, it's not so beautiful, but neither, there is just there is a small thin line, and here you have every, I mean this line, let's use some color and see what's going to happen. Col is equal to, let's say, blue kind of thing. Yeah, now you got the blue color lines, so that it is easy for you to, this is sufficient. You can just now clip again, I mean copy this into the clipboard and just carry ahead to your Word file wherever you are. Now I want to make a bar diagram. For that you have bar plot, and now I think I have to make the, let me use bar plot, and now let me use table and see what's going to happen. Yes, I got the bar plot here, female and male. I think I have blue. I can use yellow kind of thing. Now this looks a bit, you have female bar lengthier than the male bar, and you can, if you want, you can also choose to put the numbers over this. Anyway, I'm not talking about the advanced visualization techniques. I just wanted to show you the bar chart. Possibly in my another video I'm going to show you. Now this is how you need to plot the categorical data. Now you have one more categorical data, that is primary, and this primary, let us use the same strategy. This time you don't need to type the entire statement once again. You just have to change the name of the variable. This time you have education. You can press tab button here in order to make, since you have the three categories, higher, primary, secondary, we have very less number of individuals who belongs to this category primary, and the next followed by secondary, and the highly peak, I mean the lengthy bar seems to be individuals who belongs to this category higher. And this is how you can make the bar plot for education. Now I'm going to make the plot for satisfaction. Actually this is categorical data. but unfortunately I don't have the categories here because I created this data using a function ran between inside Excel. That is why I have 1 to 5 categories. Now suppose if you would like to convert this into categories, you can do that, but I don't like to waste my time. I need to spend a couple of minutes. Now you can do just one thing. You can make a table of MyDF S1 and let's say I can just say education. Is it possible? MyDF education, and then yeah, I got the table. Now let me plot this table and see what's going to happen. Frankly speaking, I don't know what is going to happen. Yeah, you got a kind of here you have secondary, higher, and you have the categories 1 to 5. Now you see the one of the blocks, or say rectangle, which belongs to higher versus 1. That is higher versus 1. This is the maximum frequency in this particular table. Now you can, if you wish, you can also put the values, bring up values in this. I mean, this is what is called the title. Title seems to be ugly, but you can just change the title by simply adding a particular parameter called main. This is gender versus no, I'm sorry. This is S1 versus education. Yeah, education kind of thing. You see, now you can change the title. You can also control the other parameters, but here it is very intuitive to make some kind of sense out of this plot, that the major uh, the response higher to the category 1 in S1 seems to be very much potential in our survey, followed by each of these responses, and then respectively. I mean, you can just go ahead in adding more and more sense to this plot, something like that. Now you can also make a kind of, now I wanted to tell you one very peculiar chart which is called box plot. Box plot is very much useful to verify maybe categorical versus kind of I mean, suppose if you would like to make a chart between age and gender, we can do that by doing box plot. Box plot is also known as some whisker plots, or I forgot, MyDF age and MyDF let's say gender. Okay, now let's see what's going to happen. Oh, we have two responses in gender and against age. Now we see one, the R automatically interprets 1 versus 2. One is chubby, which means it could be female because we have 11 individuals in female. Certainly this is going to be female. And here we have male, the very narrow box, but unfortunately the I mean this is just a plot, but let me help you how to interpret the gender level differences to age is highly significant. You see, this thick line passing through this box is what is called median, and this box plot is useful for us to compare the distributions, two different distributions, with the help of medians. And you see a median of male individuals is nowhere to compare with female, kind of thing. So the differences are, suppose if I predict age, which is not meaningful, but meaningful by using gender, that is not going to be a good prediction model. So kind of thing. Now shall we do the same box plot, education versus S1? That makes, like, satisfaction levels as by the, okay, let's do one thing, satisfaction levels as by the gender. Now I already have this command here. I have satisfaction levels by the gender. Now I have, okay, I'll just change gender versus, okay, that's fine. Gender versus satisfaction levels S1. Oh, I'm sorry, I think it is S1. Yes, it is. It comes in the same fashion. So that too, actually there are significant differences, gender level differences to satisfaction levels in this. Okay, so this way we can just make keep adding sense to our data by creating visuals. This is just for this video. In my next video I'm going to proceed ahead with predictive analytics. I just wanted to show you how to make the plots. There are quite a few other, there are infinite number of opportunities to, as far as these visualizations are concerned inside R is really a beautiful programming language which has umpteen number of ways, or really unreasonable, I mean more number of ways to create visualizations. Not only visualizations, also advanced visualizations like animations and also kind of image editing and etc. Now this is for this video. If you like my video, please press like and stay tuned for the new content, and don't forget to subscribe to my video channel. Thanks a lot once again for watching my video.